This is part 3 of the chemical calculations or mole calculations mind map. Now in this mind map, we're going to look at limiting and excess reactant. Now what is limiting reactant? What is excess reactant? Now let's consider this example here. Let's say you open a cake shop, okay? And your shop sells the cake in such a way that one cake in one box, and you sell the box of cake to the customer. Okay, put one cake in one box. So if you have 10 cakes and 8 boxes, so how many boxes of cake can you sell? So obviously it's 8 boxes of cake, right? Now what if you have 11 cakes? How many boxes of cake can you sell? You also can sell you only can sell 8 boxes only. So which means 8 boxes, the number of boxes limit the number of boxes of cakes which you can sell. Okay, so regardless of how many cakes you have, okay, you have 20 cakes, you only can sell 8 boxes of cake because the limiting reactant in this case is the boxes. So boxes is the limiting reactant. So this is like a chemical equation. So this is the product. So the product is limited by the number of boxes. So the limiting reactant in this case would be the box, and the excess reactant in this case would be the cake. Okay, so amount of product formed depends on the amount of limiting reactant. In this case, the number of boxes available. In this case, the number of boxes of cake that you can sell depends on the number of boxes, because the number of boxes is the limiting reactant. So this is the first very important concept. Okay, let's look at another scenario. Let's say you have another cake shop, and then the way your shop sells the cake is in such a way that 5 cakes, put it in one box of cake. Okay, only 5 cake, put it in one box. Now what if you have 10 cakes and 8 boxes? So how many boxes of cake can you sell? So obviously it's 2. Okay, 2 boxes of cake, right? Because 10 cakes, so 5 cake in one box, another 5 cake in one box. That will give you 2 boxes of cake. But you have 8 boxes. So which means that in this case, the number of cakes limit the number of boxes of cake which you can sell. So the product is limited by the limiting reactant. So the limiting reactant in this case is number of cake, and it limits the product, the number of boxes of cake that you can sell. So the limiting reactant is the cake, and the excess reactant is the box. If one is limiting reactant, the other one must be excess reactant. Now take note, not necessarily must be the reactant with the fewest, with a smaller number would be the limiting reactant. It's not. So in this case, 8 boxes, right? 8 is fewer than 10. So 8 boxes is the limiting reactant. But in this case, the 10 cake is the limiting reactant. So it all depends on the chemical equation. Not necessarily must be the reactant with a smaller number would be the limiting reactant. Okay, it is a very important misconception. Not necessarily always be like that. So the reactant with the lesser amount is not always the limiting reactant. You have to look at the chemical equation. So limiting reactant that is completely used up. Now why is it so? Why is it so? Because let's look at the first example. You can only sell 8 boxes of cake, right? So all the boxes used up already, and boxes is the limiting reactant. So limiting reactant is always used up in the chemical equation, in the chemical reaction. And the excess reactant, the reactant that is not completely used up. Again, let's look at the first example. If you sell 8 boxes of cake, the cakes are not used up, still have 2 cakes remaining. Okay, generally in industry, the more expensive product, the more expensive reactant is chosen as the limiting reactant. So for chemical reaction in the industry, right, it's very, very difficult to have such a situation that the two reactants exactly react, finish. Okay, definitely one of the reactants would be a bit more excess. Yeah, it's very difficult for two reactants all react finish. Yeah, so the more expensive reactant is chosen as the limiting reactant. The less expensive one, the cheaper one, would be the excess reactant. Let's look at the example here. So this is an example. So everything depends on the chemical equation. So you have hydrogen, you have chlorine, you have hydrogen chloride. So this is actually hydrogen chloride gas. Okay, when you dissolve the hydrogen chloride gas into water, hydrochloric acid will be formed. Now, let's look at the experiment. Let's say for experiment A, at the start of the reaction, number of moles of reactant. Okay, let's look at it. The number of mole of reactants, you have 1 mole of hydrogen, 1 mole of chlorine. So the mole ratio is actually 1:1. Okay, so this 1 mole and this 1 mole will react to completion. That means at the end of it, you get 2 mole. So you get 2 mole of HCl. So the hydrogen and the chlorine would be all used up, all reacted ready. Okay, let's look at experiment B. You have 2 mole, 2 mole. Let's look at the mole ratio. Mole ratio is 1:1. So 2 would be to 2. So which means both these 2 moles of hydrogen and chlorine will be used up at the end of the reaction. And how much of HCl will be produced, will be formed? You will form 4 mole because 1, 1, 2. So 2, 2, 4. Let's look at the experiment C. You have 2, 5. If you have 2, 5, you see the mole ratio is 1:1. So if you have 2 here, you would need 2 mole of chlorine to react. But now I have 5 mole of chlorine. So which means your chlorine is excess. Your chlorine is excess. Your hydrogen is limiting. It's limiting reactant. Okay, so which means that at the end, the product, remember the product, amount of product always depends on the limiting reactant. Okay, let's revisit the previous page. The amount of product depends on the amount of limiting reactant. So if you want to find out how many mole of HCl would be produced, you have to look at the limiting reactant, in this case, which is 2 mole. 2 mole of hydrogen. So 2 mole of hydrogen. So 1 mole of hydrogen produces 2 mole of HCl. So if let's say 2 mole of hydrogen, that would produce 4 mole of HCl. So hydrogen will be used up because it's limiting reactant. Excess reactant is Cl2, right? Chlorine. How much in excess? Look at the equation again. 2 mole of this react with 2 mole of this. But you have 5 mole available. So 5 minus 2, there will be 3 mole is in excess. Let's look at the last example. 5, 3. So in this case, this would be the excess. This would be the limiting. Okay, and limiting 3 mole, right? 1:2. So 3:6. So you have 6 mole of HCl produced. Remember again, the product depends on the limiting reactant. Limiting reactant is 3 mole. So 1:2, 3:6, because 3 times 2. Okay, and for hydrogen, out of this 5 mole, 2 mole remains. And then for chlorine, since chlorine is a limiting reactant, chlorine will be used up. Let's look at this example, example 2. Okay, zinc reacts with sulfur to produce zinc sulfide. Identify the limiting reactant. Okay, let's look at this example here. Again, this is a typical mole concept question. So first step would be to write the balanced chemical equation. So zinc reacts with sulfur, produce. So which means that reactant, product. So zinc, sulfur, zinc sulfide. Zinc sulfide, again, zinc is a metal, sulfide is from sulfur, it's a non-metal, group 16. So form ionic compound. So zinc ion, Zn2 plus, sulfide is from the sulfur, group 16, so it will be 2 minus, because group 16 means that there are 6 valence electrons, so needs to gain 2 electrons, so S2 minus. So Zn S. This is zinc sulfide. Okay, second step. This is first step. Write down the balanced chemical equation. Second step, write down the information above or below the chemical symbols or the chemical formula. 13 gram of zinc. So you have 13 gram of zinc reacts with 8 gram of sulfur. Okay. Write down the information. Now it will be good to convert it to the number of mole. Okay, but never mind. Then so second step, third step would be the mole ratio. Okay, mole ratio of these two. So mole ratio Zn and S, 1:1, right? So you have to convert 13 gram to the number of mole, which is divided by the AR. AR for zinc, relative atomic mass, 65, and that will give you 0.2. How about sulfur? Sulfur 8 grams, right? So again, 8 divided by the AR for sulfur, look it up in the periodic table, it is 32, and that will give you 0.25. Now, since the mole ratio is 1:1, so 0.2, 0.25, so definitely 0.2, the smaller number, would be the limiting reactant. Okay, so identify the limiting reactant, which is actually zinc. So how do you explain? So zinc is the limiting reactant. Limiting reactant. Yeah, so every time when you explain or which one is limiting reactant or which one is excess reactant, always start off your explanation with the balanced chemical equation. So you can just say 1 mole of zinc needs 1 mole of sulfur to react with. Okay, 0.2. So now 0.2 mole zinc would need 0.2 mole sulfur to react. However, how much of sulfur is available? However, 0.25 mole sulfur is available. Okay, so what is available is more than what you need. So which means which means sulfur is the excess. Hence sulfur is the excess reactant, which means the other reactant, which is zinc, and zinc is the limiting reactant. Okay, so this is how you explain the limiting reactant or excess reactant. Always start off with the balanced chemical equation. 1 mole zinc needs 1 mole sulfur to react. Okay, 1 mole, 1 mole. And now you have 0.2 mole zinc, right? It would need 0.2 mole sulfur to react, but I have 0.25. So what you have, it's more than what you need, which means sulfur is the excess reactant. If sulfur is the excess reactant, zinc is the limiting reactant. Okay, so calculate the mass of excess reactant reacted at the end of the reaction. So which one is excess again? Excess is actually sulfur, right? So how much in excess? The mass of excess reactant, how much in excess? There will be this minus this. So so excess sulfur is 0.25 minus 0.2, which is 0.05. But the question wants, okay, excess sulfur, sorry. But the question wants calculate the mass of excess reactant unreacted. So the mass of excess reactant unreacted would be 0.05 times sulfur, right? The AR 32, and that would give you 1.603 SF gram. This is actually part B. Okay, let's look at example 3. Now, example 3. Ethene burns in oxygen to produce carbon dioxide and water vapor. In an experiment, 10 cm3 of ethene, so ethene is actually a gas. Okay, 10 cm3 of ethene was burned in 50 cm3 of oxygen. Identify the gas in excess and explain. So again, we always start off with balanced chemical equation. So C2H4 burns in oxygen, produces, so these are the two products, CO2 plus water vapor. So need to balance the chemical equation. Always balance the carbon or the hydrogen first. Don't balance the oxygen first, because oxygen appears in 1, 2, 3 places. So balance the carbon first. 2 carbon on the left, 2 carbon on the right. Carbon is balanced. How about hydrogen? 4 hydrogen on the left, 2 hydrogen on the right. Put a 2 here. When you put a 2 here, 2 oxygen, 4 oxygen, 4 plus 2, 6. Over here, you have 2. So put a 3 here. Okay, that will be balanced. Identify the gas in excess. Again, you have to write down this 10 cm3 of ethene, 10 cm3. So this is actually a gas. And then 50 cm3 of oxygen, 50 cm3. See? Mole ratio, right? 1:3. This is volume ratio. Mole ratio equals to volume ratio. Only for gases at room temperature. Actually, on this question, you should have mentioned that it is at room temperature and pressure. Okay, so you can actually add it in at room temperature and pressure. Then you can actually no need. Yeah. Okay, mole ratio equals to volume ratio. So how do you identify the gas in excess? So again, mole ratio, C2H4, 3 oxygen. Okay, so if you have 10 cm3 here, 1:3, right? So if you have 10 cm3, how much of this? There will be 30 cm3. Okay, so you need 30 cm3 of oxygen to react with 10 cm3 of C2H4. But what you have now is 50 cm3. 50 cm3 is more than 30 cm3. So which means the oxygen is in excess. So the gas, the oxygen is in excess. But how do you explain? Same thing. Always start off your explanation by referring to the balanced chemical equation. So you can just say 1 mole C2H4 needs 3 mole oxygen to react. So now 10 cm3 C2H4 would need 30 cm3 oxygen to react. However, 50 cm3 oxygen is available. So what is available is more than what is needed. Hence, oxygen is in excess. That's it. Okay, let's look at B. Calculate the volume of excess reactant at the end of the reaction. Excess reactant, because what is needed is 30 cm3. You have 50 cm3. So the volume of excess reactant would be just 50 minus 30. Volume of excess reactant is just 50 minus 30, that will be 20 cm cube, right? Okay, then for part C, calculate the volume of carbon dioxide produced. Carbon dioxide, it is a product. Remember, amount of product depends on the amount of limiting reactant. Okay, amount of product depends on the amount of limiting reactant, which means you have to compare the mole ratio of the limiting reactant and the product. So in this case, the limiting reactant is C2H4, so you have to look at the mole ratio of this and this. So mole ratio C2H4, 2 mole of carbon dioxide, so which means 10 cm cube. This would be 20 cm cube. So the volume of carbon dioxide is 20 cm cube. Thank you for watching. Bye bye.